I'm Anil Kumar. In this particular video, I'll summarize all the learnings of operations with vectors in R3. We are going to discuss the main topics as vectors in 3 space, in which we'll see what is a Cartesian system, what are default vectors I, j, k, how to plot ordered triples, and what are octants. Then we'll see how to represent vectors in R3. It could be done in standard unit form or in component form. We'll take a few examples. Scalar multiplication and addition are the two operations which we are going to discuss in details. I'll take up examples from previous test papers on these topics. And then, if we add 3 vectors, it makes a parallelogram. We will see how to sketch one. And as I mentioned, test questions. All the questions above will be from previous test papers. So now let's talk about vectors in 3 space. Right. So in R2 or 2 space, we are working with Cartesian plane with x and y. Now here we add z to cover for the 3rd dimension. So we also mention it as 3D. So we are calling this as Cartesian system in 3D, as it is generally called. Now this Cartesian system has 3 axes, x, y, and z. All are at right angles to one another. That means orthogonal. So I have sketched here. These are the 3 axes. We name this as positive x, that is positive y, positive z. The idea of having them as positive directions as shown is basically comes from right hand rule. So the concept here is the concept of right hand rule. Let me write down here. So that is to say, if I put the hand like this, the thumb points upwards along the z direction, right? So if I put a hand like this, right hand, the thumb will be pointing upwards in the z direction, right? So as we used I and j for R2 or 2 dimensions, here the unit vectors, I should say the default unit vectors along x is I, along y is j, and along z is k. Normally I'll be mentioning unit vectors with this kind of a symbol. Now as you can see, in R3 all these planes are orthogonal to one another. So xy plane, like the floor of your room, right? Y, z, that's the wall which you can see on one side and the other wall, right? So these are all orthogonal to one another. Any point here could be given as a coordinate point ABC, right? ABC, where A is along x, B is along y, and C is along z. So these are multiples of I, j, k. So basically, you could say that these are the components along I, j, k, right? These are the components along I, j, k. So I'll kind of skip from here to the next topic, since that is related with the ordered pair is related with these two. So let us say I move 3 units here in this direction. Let's say 1, 2, and 3. Then this point here will be represented as 3, 0, 0, since I moved 3 units towards positive x-axis. Now if from here I move, let us say 4 units right, so let's say 1, 2, 3, 4. In that case, this point will be referred to as, since we moved 3 towards x, 4 towards y, till now we haven't moved along z direction, so that point represents 3, 4, 0. And if I move downwards from here, let us say 1 unit. Let's say 1 unit. In that case, the point reached will be 3, 4, and minus 1, since we went against the direction of positive z-axis. Now, connecting from origin to this particular point, if I connect this point with the origin, with tail at the origin, which will be mentioned as 0, 0, 0, and head at this point, let me call this as P, origin as O. In that case, the vector OP is represented in 3D. Do you see that? Vector OP is represented in 3D. In component form, I will write OP as equal to 3, 4, minus 1. And in standard unit form, unit basis we take as ijk, right? So this basis we take as ijk, as I just explained here initially. It will be represented as 3i plus 4j minus k, right? So ijk will always be treated as a unit vector along the direction x, y, and z. So that becomes in standard unit form, the same vector OP, right? So I hope this point is very clear how to represent these vectors. And A, B, C, that kind of representation, like in coordinate plane you had the x and y, is termed as order triple, right? So this is called order triple. So remember this, that is the order triple. Okay. Now there is one more term which is octants. In R2, we have 4 quadrants, right? So let me give you a link. In R2, we have 4 quadrants. In R3, we have 8 octants. Now what are these? Let me describe here. So there are 8 octants. These octants describe the position of the vector, where the vector is. So in this plane we can see right side and the left side. So we normally, for octants, we say right side or the left side. Now in each side, the vector could be on top or in bottom, right? So on each side, it could be above or below. So it could be above or below, right? So that gives you 8 different positions, right? So it could be on the right, back and front, above, below, right, and then we have above, below, and also back and front. And the other combinations are back and front. Back and front. So that is how we are actually describing the octants, right? So the position which we just mentioned here, this particular vector, is on the front side, correct? Right front. So this position for P will be right. It's in the front and below. So that becomes the octant in which point P will lie, I should say point P will lie, which is 3, 4, minus 1, right? So it's good to say that point P rather than the vector as such, right? So there are 8 octants to remember, and that is how we show where the point lies. So if it is somewhere in the space, that is how you could describe it. The other way to describe is like this point lies on the x-axis, 3. This point lies on the x-axis. Point 340 lies on xy plane. So we could write this point as on xy plane. This point is on x-axis, and the point P lies on the octant right front below. That is how you're going to describe the position of points in R3, correct? Scalar multiplication is what you saw here. If I write I, then 3i is scalar multiplication along x-axis. So it's a scalar multiple. So as we had been doing, k times, let us say 1, 2, 3, means that you multiply each component k times. So if whenever you do scalar multiplication, you get a vector which is collinear. We'll take up now examples relating to all this. I hope that'd be better. Right? So we got the basic concept. Now let's move forward and see some questions from previous test papers. The very first question here is, plot the point A 2, minus 3, 4, B 0, 3, 4, and C 0, 0, minus 5. Describe the location of each ordered triples. Right? So you understand these are called the triples, ordered triples. You have to plot them and describe their location, right? So the location could be on the axis, it could be in a particular plane, or it could be on one of those 8 octants, right? So that is the whole idea. So this is positive x-axis for us. This is positive y, positive z. Let's take the point A first. So the point A is 2 units towards x, so we'll say 1, 2. Minus 3 means y is positive that side, so minus 3 means 1, 2, 3. Let's say this is minus 3. And then 4 up. So 4 up will be 1, 2, 3, 4, right? Like this. So that's the end point, and you can always join to represent your vector OA, correct? That is how you will actually make it. Now, this could actually be made by showing you a parallelepiped. So that made the base. Do you see that? This is the base for us, kind of in XY plane. This is the base in XY plane. Now we went up from here to by 4 units. So all these points could go up by 4 units, kind of like this. Correct? And what you see here is a box. And in this box, OA represents your vector. And if you are representing the vector OA, we say OA is position vector. So any vector whose tail is at the origin will be treated as position vector. The idea is to find now what is the position of, how do you describe location of A? Tell me that. What is the location of A? Now here we move towards the X, that means we are on the front side, so we'll say front. Then we move towards left, right? So it's left, and went above, so top or above. So sometimes we use the word top or sometimes above. So that becomes the position of A. So this octant is on the front left top octant. Is that clear? Okay, so we are on the first one. Now let us look into the second and third, point B and C. Point B is 0, 3, 4. That means you're not moving along the x-axis at all. You are still at the origin. 3 units, 1, 2, 3. Let's say that is along y, right? So this is 3. So I should say 0, 3, 0. Okay. 4 units tops. So you go 4 up. Let's say this point, right? So this, I'm not making the boxes now. I hope that is very clear. So this is point B, which is 0, 3, 4. Now can you describe me the location of this particular point? As you can see, this point is in YZ plane. So this point is in YZ plane. Plane in front of you. Do you see that? Just that wall. The last point here is point C, which is 0, 0, minus 5. So 0, 0, minus 5 means we are not moving along X or Y, but we are going down by 5 units. Let's say that is down by 5 units. And this point here will be treated as 0, 0, minus 5. And this point is located where? On Z-axis. So that is how you could actually describe any point in R3. So a point in R3 could be described as a point on one of these axes or one of the planes. The planes here are, as you can see, we have a plane which is right there, and this is your XY plane. The plane right in front of us is YZ plane. And the plane on this side is XZ plane. So that is how you could actually describe any point. So I hope that's very clear. So let's move on and do question number 2. So I hope how to describe a point in space is absolutely clear. Now let's move on and see how to represent vectors in standard unit form or in component form. Question 2a is write OA minus 2, 3, 1 using standard unit vector. So when we say standard unit vectors, we want to write in terms of I, J, K, right? So we could write this as vector O equals to minus 2i plus 3j plus k, right? So that's how we could do it. I, J, K are unit vectors along x, y, and z direction. 2b is write vector OB, which is 2i minus j plus 4k in component form. So this is already given in standard unit vector form. So OB now could be written as in component form as 2 minus 1, 4. Correct? 2c is find the magnitude of vector AB, determine unit vector AB. So there are two parts to this. First, we have to find magnitude of vector AB. Now, what is vector AB? Now, let's think about this. So in any plane, we just take in general, right? So in any plane, let us say we are given two vectors, OA and OB. Let's say this is vector OA, and then we have a vector which is kind of OB right there. So what we are showing here is two vectors OA and OB. So this is O, that is A, this is B. Now when I say vector AB, that means it is this vector, correct? So that becomes vector AB. So this is vector AB. Now you can see from the vector addition that vector OA plus AB is equal to OB, right? OB. So AB, vector AB could be written as vector OB minus OA, correct? So these are simple operations in vectors. We can find vector AB as OB minus OA. So you can see here, position vector B is the head and that is the tail, right? So this is basically the head position. You can think like this, right? That is the tail position. And their difference gives you the vector as such. You get an idea, right? So that is how you should do it. Now we know what AB is. Let's calculate the value. So you could do it in either of these forms. Let me use the component forms. We'll do B minus A, position vectors, right? So we could write this as 2 minus 1, 4 minus 2, 3 and 1. So that really means we have to subtract their corresponding components, right? So we have written in component form. This is the component form, and we have written in component form. These are all new terms for you now, but soon you'll be very familiar with them. So 2 minus minus 2 will give me, let me write 2 minus minus 2. Then we have minus 1 minus 3. Okay. And then what we have is 4 minus 1. Which gives us 2 plus 2 is 4. Here it is minus 4. And then 4 minus 1 is 3. So that becomes the vector AB, right? So I could write vector AB also as 4i minus 4j plus 3k. Is it okay? So either way, so that becomes your unit standard form, right? And this is the component form. Perfect. Now we need to determine unit vector AB. How do we find unit vector AB? For that, we have to first find the magnitude of vector AB. Magnitude is a square plus b square plus c square square root, right? So it is 4 square plus minus 4 square plus 3 square square root. Let's use the calculator to find the answer. Okay, so we have square root of 16 plus 16 plus 9, which is equals to square root of 41. So that becomes the magnitude of vector AB. Now, what is unit vector AB? So when I say unit vector AB, basically it means, I should not have written like this, it basically means the vector AB divided by its magnitude. That is the unit vector. You get the idea, right? So, and we represent unit vector with this symbol. So that becomes a unit vector AB. It is equal to the vector which is for us 4 minus 4, 3. And we are going to divide this by square root 41. Correct? So that is how you get unit vector AB, right? Now let me write down this unit vector AB as our answer, which is AB unit vector, right, is equal to 4 over square root 41 minus 4 over square root 41 and 3 over square root 41. Is it clear? So that is how we'll write this unit vector, right? So I hope it's absolutely clear. So basically, unit vector is a vector in the same direction with magnitude of 1. And how do you get it? You get it by dividing the vector by its magnitude. So the unit vector is equals to the vector AB divided by magnitude of AB. Perfect. So that is how you should find it. Okay. Let's move on and do question number 3. Question number 3 and 4 are from previous test papers, and we'll understand the concept of scalar multiplication and its relation with collinear vectors while solving these questions. Question number 3. Write a vector in opposite direction which is collinear to OP equals to 2i minus 3j plus k. Second part of this question is, how many of such vectors are possible? So collinear means along the same line. So collinear means along the same line. That is important, right? So when we are saying collinear means along the same line. So it could be in opposite direction. Very important to understand. It could be in opposite direction, right? Now in vectors, if I have to give opposite direction, it becomes like OP becomes PO basically. So the direction reverses, right? So if I have to give opposite direction, I could write this also as PO, right? This is OP. So that will be negative of whatever you have, 2i minus 3j plus k. Do you understand? So that's probably the simplest way of giving it. So we get minus 2i plus 3j minus k. So that becomes a vector which is in opposite direction to the given vector. Is it okay? And opposite direction vectors are always collinear. Important to understand, right? So let me write down. So it is so I hope that's clear. Now, second part of this question is how many such vectors are possible? Now, can you answer that? So the answer for this part is infinite. Since we could multiply it by any number, and that's where the scalar multiplication comes into picture. Even multiplying by minus is a scalar multiplication. You should understand that, right? So I could give another vector, let's say OS, for example, where I could multiply this by 3, for example. So I could say minus 6i plus 9j minus 3k, correct? So that could be another one. You could multiply by any number. It has to be a real number. That's all. So if you multiply by any real number, you get your answer. And that is what it is. So there are infinite such vectors. Now let's look into question number 4. It says, find A and B such that the vectors u and v are collinear. So we are given vectors u and v. Let me make it lowercase u. 3b minus 4 and v is a, 10, 8. So let's write down. So we have 3b minus 4 as the vector u. And here we have vector v, let me write down here itself, as a, 10 and 8. So when we say that these vectors are collinear, in that case we are trying to say that vector v is some constant times vector u. Now here you can see that these two numbers are in the ratio, right? And the constant seems to be minus 2, right? So we know 8 divided by minus 4 is minus 2. So we know in this case, vector v is minus 2 times vector u. So if you apply this, that v is minus 2 times vector u, then you can get what a is. So a equals to minus 2 times 3, which is minus 6. And b is equal to, now in this case b is on that side, so b is vector u, right? So this also implies that vector u is minus half of v. Is it okay? The reverse operation. So this time when you go down, u to v, you're multiplying by minus 2, but when you go in this direction, then you are dividing by minus 2, right? So we'll divide 10 by minus 2. So it is 10 divided by minus 2, which gives you minus 5. So those are the answers, correct? So that is how you write. So a equals to minus 6 and b equals to minus 5. So I hope that is absolutely clear, right? Let's move on and take up the next question, which is question number 5. It is again on scalar multiplication and the concept is collinear vectors. Question 5 is, given vectors p, q and r, show that p, q and r are collinear. That's part A. And part B is, determine ratio in which q divides pr. That's interesting. See, what we are saying here is that we are given points p, q, r are collinear. So that means something like this. So we have a point P whose coordinates are 1, 3, minus 2. Then we have somewhere point Q whose coordinates are 2, 1, 1. And then we also have point R, whose coordinates are 6, minus 7, 13. So these are the three vectors. We have to show that PQ are collinear. So how do we show that? So the way to show it is that if I could say that PQ is a scalar multiple of QR, right? So that means they are collinear, right? So QR. What is PQ? So PQ means this minus this. So this time what I will do is, to find PQ, we'll write in this form, vertical form. So we get 2 minus 1, 1 minus 3, 1 minus 3, 1 minus minus 2. That means 1 plus 2, right? That is PQ. K times Q to R. Q to R is 6 minus 2 is 4. Minus 7, minus 7, minus 1 is minus 8, and 13 minus 1 is 12. Right, so that is K times this. Okay, so let me rewrite these numbers. Let's do it here. So what we get here is 2 minus 1 is 1, this is minus 2, and that is 3, equals to K times 4 minus 8 and 12. Now from here, you see that K is 1/4, right? So K is 1/4. To make them equal, 1, 2, 4, so K has to be 1/4. So this implies that K equals to 1/4. Now since we have a constant, it means they are collinear, right? So we can say that since PQ equals to 1/4 of QR, these are vectors, right? That means they are collinear. So we are saying PQ, if it is PQ is 1/4 of QR, that means if PQ is 1, QR is 4. Do you see that? That's what we are trying to say here. Is it okay? So now we can answer the second part also, which is determine ratio in which Q divides PR. So part B is Q divides PR in what ratio? So we can say PQ over QR is equal to 1/4, right? So it divides in the ratio of 1:4, right? So 1:4. So that is how you could answer this question. So I hope it's absolutely clear. So in this particular case, since we know that they are collinear, we don't have to find the magnitude of distance, right? So we don't have to use the distance formula. We get it direct, as you can see here. I hope that makes sense. Let's move on and answer the next question. We are almost at the end. I hope most of the concepts are very clear. Question number 6 is based on combination of vectors. It is given PQRS is a parallelogram with vertices P 1, 2, 3, Q 3 minus 3, 2, R, X, Y, Z, and S equals to 5, 1, 6. Determine the coordinates of R. Now in such questions, you need not plot them since they are not saying to plot. If they tell you to plot, then you have to, right? So what I will do here is, I'll just construct a parallelogram. So opposite sides are parallel and equal. That's what. And we'll name them in an order, right? P, Q, R, and S. Point P is 1, 2, 3. Q is 3 minus 3, 2. R is what we need to find, X, Y, and Z. S is given to us as 5, 1, and 6. Perfect. Now, you know that these sides, opposite sides are equal and they are also parallel. Now that gives you an idea. The idea is that SP is equals to RQ, right? Or you can say PS is equals to QR. Right? So PS is QR. So when I say PS, that means 5 minus 1, right, is equals to x minus 3, right? So we have 5 minus 1 is equals to x minus 3, x minus 3. Do you see that? So 5 minus 1 is 4, and we can bring 3 here, and we say x is equals to 7. So we get coordinate 7 for x. This is one way of doing it. The other way is what you can also do. Now let me show you with the y values. So we go from 2 to 1, that means minus 1, right? Going from 2 to 1 is minus 1. So I'm doing minus 1 here. I do minus 1 from 3, so I get minus 4. Do you see that? So I get minus 4 for y. Now this is very fast, correct? Let me show you algebraically also. So we do 1 minus 2. 1 minus 2 is equal to y minus 3. So that makes it 1 minus 2 is minus 1. And so y equals to minus 3. So which gives you minus 4 as we found. Perfect. So you could adopt any one of these techniques to find the third point. I prefer to write them straight. So what I'll do again is, from 3 to 6, I have to add 3, right? So I'll add 3 to here and get my z. So 2 plus 3 is 5. So I get my point 5. Do you see that? So I say that my point R location is 7 minus 4, 5. Is it okay? We should test it from the other side also. So if I'm going from P to Q, I know that side, these are also equal, parallelogram, right? So when you go from here to there, 1, 2, 3, you are adding 2, correct? So if I add 2 to 5, I get 7. If I'm going from 2 to minus 3, I'm doing minus 5. So let me do minus 5 here, so I get minus 4. Now if I'm going from 3 to 2, that means I'm going minus 1. So let's go minus 1 on 6, which gives us the 0.5. So you reach the same result. But I hope this strategy, which I've just shown you here, works, right? So you could do like this or like this, as you wish. Okay? So I hope that brings us to the next question, which 2 more to go. Question number 7. Combination of vectors operation. Given points u and v, determine 2u minus 3v in standard basis form. Standard basis is in which it is written here, right? So we'll do the algebraic operation. We want 2u minus 3v, right? So that basically means 2 times the vector u, which is 2i plus 3j minus k, right? Minus 3 times vector v, which is minus 3i plus 2j plus k. That's what it means. So whenever you do the vector operations, let's multiply this first, and then we'll write 4i plus 6j minus 2k. Here we get minus 3 times this is minus 9i, and we're keeping negative outside. We're just multiplying by 3 inside. So we're doing plus 2 times 3 is 6j and plus 3k. So we just multiplied by 3, kept minus outside. Anyway, so now we can just combine these terms. So 4i, so in as far as I is concerned, 4 minus and minus becomes plus. Do you see that? So it becomes 13i. 6 minus 6 is 0. So it's just 0. So I'm not writing anything. Minus 2 and minus 3. That means minus 5. So it is minus 5k. Okay. I prefer to write unit vectors with this symbol, which you may adopt, but ijk as such stand for unit vectors in x and y and z direction respectively. Is it okay? So that is how you get combination. So whenever you're doing combination, each component is added, right? So each component is added, right? Now let's do the last question here, which is question number 8. We will sketch parallelepiped from given position vectors. I'd like you to pause the video, copy the question, sketch, and then look into my suggestions. Thank you. Question number 8. A parallelepiped is determined by the vectors OA minus 2, 3, 5, OB 0, 4, 1, and OC 0, 6, minus 2. Sketch parallelepiped and find coordinates of the vertices. So there's something missing here, but I hope you understand. So part 1 is to sketch the parallelepiped, and part 2 is to find the coordinates of the vertices. Now whenever you're doing this kind of a question, I like you to use different inks. That will always help. Okay, so let's see. So we have 0, 4, 1, 0, 6, minus 2, minus 2, 3, 5. All of them are on the right side, right? So all of them are on the right side. So to save some space, I'm going to draw like this. So that becomes my XYZ coordinates, R3. Now, I will prefer to sketch OB and OC first, since they seem to be with 0 x-axis, so they're on this side, and then we'll take care of OA, right? So let's do OB first. OB is 0, 4, 1. So that's starting 0 x-axis. Let me write down XYZ also, right? And then we will do the rest. And that's the original. So let's use lighter ink. So we have OB, which is 0, 4, 1. So 0, 4 along the y-axis. So let's say 1, 2, 3, 4, and then 1 up. So 1 up, 1 up. So that gives me the vector, position vector OB. So whenever it is from O to B, it becomes a position vector. So this is my point B. Now let me take the next one, which is OC, 0, 6, minus 2. So 0, we have already gone 4, 5, 6, and we'll go down 2 units, 1 and 2. So we get to this point, which is, let's say now this is C, OC. So any two vectors form a plane. Do you see that? Any two vectors will form a plane. So let's complete this plane first. So if I go from C in the same direction as B, that long, correct? So kind of like this. So I reach some point, this is not so good. Okay, so kind of like this, right? So that becomes my B dash, and I'll call this point as D, and I'll complete this plane by joining B with D. Is it okay? Now, as we are joined, we got one plane at the bottom. Here I'll label them. So we have 0, 0, 0. And point B is given to us as 0, 4, 1. C is given to us as 0, 6, minus 2. What is D? D is combination of B and C, right? So from B you went, so add them up. So add these up. So D will be 0. 4 plus 6 is 10. And 1 minus 2 is minus 1. Does it make sense? So there it is. Okay. Now let's consider point A, that is position vector O will look into, OA, minus 2, 3 and 5. So minus 2 will be in this direction. Is it okay? So that is minus 2. 3 we are going in this direction. 1, 2, 3, 4. That kind of a thing will take. So we'll go 1, 2, 3. So we are here 3 and 5 up. So we go 1, 2, 3, 4, and 1, 5. So let's reach this point, and we'll call this as OA. So that's OA for us. So the point A, and the coordinates are -2, 3, and 5. So let's do with the back side first. So if I'm going from B, so I'll draw another one like this. From here, it will actually shoot into my written material, kind of like this. And we can actually complete this up. And once we complete, we can get the points. And those points will be combination of OA, and we added OB to it. So this point, let me call this point as E, for example. And the coordinates will be, we have to add these. So it is -2, 4 plus 3 is 7, and 5 plus 1 as 6. So we get the point E now. So we are on the back side, so we'll go with D now and combine. So we have to draw a line which is parallel to BD from here, right? So parallel to BD from here. And from here, we have to draw a line, a vector, which will be parallel to OA. So from here, we'll draw a vector which is parallel to OA, which is kind of like this. And coordinates of this point will be, we have to now add to this, which is E, the location of D, right? So we could add that. So basically what we should do is, we can actually from D, we can add what OA is. So we could add from D, because we went from D, OA. So we will add -2, 3, 5, 2, 0, 10, -1. To get this point, let me call this point as F, and this point will be -2, 10 plus 3 is 13, and -1 plus 5 is 4. So I hope you get it, right? So from D, it is like this. And now we could go from C also and add OA on C to get to this point, correct? And that should be somewhere here, right? So somewhere here we'll add from C this point, and we'll get our point G. Now that's the last point. Let me complete the whole structure which we have. So we have kind of like this, and there you go. What are the coordinates of point G? Can you tell me that? So on C, we can add A, correct? So it is OC plus OA, which gives you G. So the coordinates for G will be -2, 6 plus 3 as 9, and -2 plus 5 as 3, correct? So that is how we get all the points on our parallelepiped. So I hope the structure is clear to you. How should you be drawing? Individually, these planes are all parallelograms. These are all parallelograms as shown here, correct? So that is how it could be sketched. I hope it helps. Feel free to write your comments, share your views, and with that, we give you a complete review on operations with vectors in R3. If you like and subscribe my videos, it'll be great. Thank you, and all the best.